Imagine waking up in a dark cave, your body shaking with fever. Your skin burns, yet the icy air of the Ice Age cuts to your bones. Around you, your tribe looks on helplessly. No medicine, no cure, no hope. This wasn't the flu or a cold. This was a disease that killed swiftly, painfully, and without mercy. Long before modern pandemics, ancient humans faced plagues that could wipe out entire groups in days. The shocking truth: some of these diseases were far deadlier than anything humanity faces today. Picture this: a small band of early humans huddles in the mouth of a cave. The night air is sharp, filled with the distant roar of predators, but inside the cave, something far more dangerous brews. A child coughs violently, his body racked with fever. His mother clutches him close, desperate, knowing she has no medicine to offer. By dawn, his breathing slows, his tiny chest falls still, and another life is lost to an invisible killer. Long before recorded history, diseases stalked humanity like shadows. Parasites clung to unwashed skin, festering wounds turned lethal, and fevers spread silently from one body to the next. For prehistoric humans, survival wasn't just about outrunning a saber-toothed cat or finding enough food. It was about surviving the unseen: infections, parasites, and plagues that left no claw marks but claimed more lives than predators ever could. Welcome to Before Flame. Fire. If you enjoyed traveling back in time with me, don't forget to hit like and subscribe so you never miss the next journey into our ancient past. Imagine drinking from a cold, rushing stream. The water looks pure, glistening under the sun. But hidden inside are parasites and bacteria waiting to invade. Days later, the stomach cramps begin, then fever, then weakness so profound you can barely walk. In a small tribe, where every hand is needed to hunt and gather, one sick body could doom the group. And unlike today, there were no cures. No antibiotics. No medicine. Just trial and error, herbs chewed, smoke blown, wounds wrapped in hides. Sometimes it worked. Often, it didn't. Disease wasn't rare. It was constant. A presence woven into the daily life of every human who dared to wake up in the Ice Age. If we could step back tens of thousands of years, we'd quickly realize that the true predators weren't always the beasts of the wild. They were diseases born from the very environment humans depended on. Picture this: a freshly hunted deer dragged into camp, blood still steaming in the cold air. The tribe gathers, hungry and eager. But the meat carries more than nourishment. It harbors bacteria, parasites, invisible killers. Without fire to cook it thoroughly, or knowledge of how pathogens spread, one meal could infect the entire band. The people may have thought spirits or curses were to blame, but in reality, microbes were waging war inside their bodies. And then, there were wounds. A jagged cut from stone tools, or a bite from a predator that didn't quite finish its attack. Even the smallest gash was dangerous. With no clean bandages, no antiseptic, the wound festered. Pus gathered, fever spiked, and infection spread. What began as a scratch could end in death within days. Diseases didn't just strike individuals, they reshaped entire groups. A fever sweeping through a tribe meant fewer hunters, fewer gatherers, and weaker defenses. In a world where every day was a test of survival, illness was a silent thief that stole not only lives but also futures. Yet, somehow, our ancestors endured. They observed. They adapted. They noticed that certain plants eased pain, that fire helped ward off sickness, that isolation of the sick sometimes kept the rest alive. Primitive science, born out of desperation, laid the earliest foundation of medicine. Disease was brutal, but it also forced humans to learn. And that learning, however fragile, was part of what kept them alive long enough to become us. But here's the haunting truth: prehistoric diseases weren't isolated tragedies. They shaped the course of human evolution itself. Think about it. When small groups of humans lived tightly together, huddled in caves or shelters, one cough could echo like a death sentence. Respiratory infections, parasites in the gut, even mysterious fevers spread quickly in close quarters. And because survival was already so fragile, even a single outbreak could wipe out families, clans, or entire communities. Yet, hidden within this suffering was a strange kind of natural selection. Those who survived illnesses often carried genetic advantages, stronger immune responses, adaptations that would be passed on to their children. This is why, even today, traces of ancient diseases can still be found written in our DNA. Some of the strengths we take for granted, resistance to certain viruses, or the ability to digest specific foods, were forged in the fires of prehistoric plagues. But for our ancestors, this was no comfort. Imagine the terror of watching your child shiver with fever, with no explanation, no cure. Imagine not knowing whether the next hunt would feed you or infect you. Imagine lying awake at night, not from fear of predators outside the cave, but from the silent enemy already inside your body. And this was only the beginning. As humans spread across continents, they didn't just encounter new landscapes and new predators. They encountered new diseases, deadlier and more mysterious than the ones before. Each migration wasn't only a journey of discovery. It was a gamble with survival. The story of disease in ancient times wasn't just about death. It was about transformation. And it set the stage for battles even more terrifying in the chapters to come. As Homo sapiens left Africa and began their long migrations across continents, they carried more than tools, fire, and survival skills. They carried something invisible: pathogens. With every step into new lands, the risks multiplied. Picture a small band of humans entering unfamiliar forests. The air is damp, the ground teeming with insects. Mosquitoes bite, leeches cling, and strange fevers burn through the group. These weren't just nuisances, they were lethal. Malaria-like diseases could cripple entire hunting parties, leaving survivors too weak to gather food or defend themselves. But it wasn't only parasites. As humans spread into colder climates, they found themselves packed together in shelters, huddling around fires to escape the ice. Close contact meant respiratory diseases thrived. A single infected person could doom a group of 20, especially when medicine didn't exist beyond herbs, chance, and sheer luck. And then came something even more dangerous: contact with other human species. Neanderthals, Denisovans, and early Homo sapiens weren't just rivals for land. They were also carriers of unfamiliar germs. A disease harmless to one group could be catastrophic to another, just like smallpox devastated Native Americans thousands of years later. Imagine those first meetings, not only tense with weapons raised, but unknowingly laced with microscopic killers. This spread of disease didn't just happen by accident, it shaped history. Populations that survived these encounters grew stronger, while others simply disappeared. In many cases, germs decided the winners long before battles did. Every new horizon humans crossed was a gamble. A lush valley might offer food and shelter, or a new sickness that stalked them in silence. Migration was not only about conquering nature, it was about surviving an invisible war. By the time humans reached Europe and Asia, the stakes had escalated. The cold, harsh climates of the Ice Age weren't the only threat. Disease had become an invisible predator, shaping the survival of entire species. Neanderthals, who had lived in Europe for hundreds of thousands of years, had immunity to certain pathogens their immune systems had adapted to over generations. Homo sapiens, arriving from Africa, carried different diseases. A simple cough, an infected cut, or even exposure to contaminated water could trigger deadly outbreaks. These microscopic threats acted like silent hunters, reducing populations long before humans even encountered each other with spears or stone axes. Evidence from ancient DNA shows traces of these survival battles still exist in our genes. Modern humans inherited immune system adaptations from Neanderthals and Denisovans, genes that helped fight off viruses and bacteria. In a sense, early human migrations weren't only about finding new lands. They were about exchanging biology, and sometimes, diseases became unintended gifts that strengthened future generations. In these fragile communities, cooperation became a life-saving strategy. Groups had to share knowledge about safe water, edible plants, and protective shelters. A healer's wisdom, which plants cured fevers, which roots could purify water, could mean the difference between life and death. Every child that survived infancy was a victory against a world that had little tolerance for mistakes. It's easy to imagine these ancient humans as brave hunters and gatherers, but in truth, their survival depended on microscopic battles waged in the shadows. Disease was an invisible teacher, relentless, impartial, and unforgiving. Every step they took into new territories was not only a conquest of land, but also a gamble with unseen enemies, shaping the destiny of species long before history was written. The collision of species brought more than just competition, it brought opportunity and peril. When Homo sapiens met Neanderthals and Denisovans, it wasn't only a test of strength and strategy, it was a test of immunity. Pathogens traveled silently between groups, leaving some populations decimated while others adapted and survived. Survival was no longer just about hunting skills or fire mastery. It was about biology, knowledge, and timing. Some humans carried immune advantages that allowed them to thrive in regions others could not. Others succumbed quickly, leaving gaps in populations and opening territories to the more resilient. These invisible battles shaped migration routes, alliances, and even the interbreeding patterns that would leave genetic legacies thousands of years later. Humanity, it seems, has always been a story of negotiation, with nature, with rivals, and with microscopic forces that could not be tamed by strength alone. And yet, there is a remarkable resilience in the face of these challenges. Communities developed early public health measures, even if not named as such. They avoided contaminated water, separated the sick, and passed down knowledge about medicinal plants. Culture, language, and cooperation became as essential as spears and shelter. Knowledge became survival, and teaching it was a silent rebellion against the ceaseless march of disease. As sapiens expanded, they carried these lessons with them, blending them with new strategies learned from encounters with other species. The survival of the fittest was no longer about muscle. It was about minds, memory, and collaboration. The spread of humanity was also the spread of immunity, adaptation, and culture. A fragile but unstoppable chain that linked generations in a constant dance with the unseen world of pathogens. In the end, disease did not stop humans. It forced them to evolve, smarter, stronger, and more cooperative. Every migration, every settlement, was a story of triumph over invisible adversaries, a testament to the endurance and ingenuity of our species. By the time humans had spread across continents, disease was no longer a distant threat. It had become a shaping force of civilizations. Epidemics of the ancient world didn't just kill individuals, they redirected the flow of history. Tribes that survived gained territory, resources, and genetic advantages. Those that failed left gaps, forgotten by time, their lessons buried in the soil. The pathogens of the Ice Age and beyond were relentless, yet humans developed strategies that would echo for millennia. Populations learned to control water sources, store food safely, and recognize early signs of infection. Knowledge about plants with antibacterial or antiviral properties became invaluable. In this sense, survival depended not only on strength but on observation, memory, and the ability to teach, a kind of early public health that shaped the very structure of communities. Interestingly, these ancient epidemics may have contributed to our social evolution. Cooperation, shared responsibility, and care for the vulnerable weren't just moral choices, they were survival strategies. Families and tribes that embraced these behaviors strengthened their chances of endurance. Language, ritual, and culture became intertwined with biology. Every story told around a fire, every instruction on avoiding contaminated water, every medicinal practice passed down was a thread linking generations in a fight against invisible enemies. Disease, in effect, became a catalyst for intelligence and culture. The harsh lessons of infection forced humans to innovate, adapt, and collaborate in ways that no predator or climate could achieve alone. By the time written history emerged, humans had already accumulated tens of thousands of years of practical epidemiology, etched into their genes, their behaviors, and their communities. As humans settled into larger communities, disease became a double-edged sword. Dense populations allowed for greater collaboration, trade, and cultural growth, but they also provided fertile ground for pathogens to spread. Smallpox, tuberculosis, and influenza may have been lurking in ancient camps long before history recorded their names. Each outbreak tested not only survival but social cohesion. Tribes that could care for the sick, isolate the infected, and maintain resources had a higher chance of passing on their genes. Interestingly, genetics tells us that ancient epidemics left permanent imprints. Survivors carried immune advantages that shaped the evolution of modern humans. Certain alleles, genetic variants, that helped fight bacterial or viral threats were selected over generations. In some populations, these adaptations remain today, giving subtle clues about the invisible battles our ancestors faced. The psychological impact was just as profound. Constant awareness of invisible dangers may have accelerated cognitive development. Humans learned to predict, plan, and respond to threats they could not see, smell, or hear. Rituals, taboos, and early medicine evolved not as superstition, but as survival strategies. Fire, cooking, and fermentation weren't only about nutrition, they reduced microbial risks. Clothing and shelter offered protection not just from weather, but from disease vectors. Through this lens, epidemics were architects of human ingenuity. They forced communities to innovate socially, biologically, and technologically. Our ancestors' fight against disease wasn't just about living another day. It shaped the very intelligence, cooperation, and resilience that define Homo sapiens today. By the time humans spread across continents, disease had become a silent companion, sometimes a killer, sometimes a teacher. Tribes that survived were those that adapted, innovated, and formed alliances to share knowledge about safe water, edible plants, and strategies to avoid outbreaks. Social structures, rituals, and even storytelling carried critical survival information, encoded not in books but in memory and culture. Some of the deadliest epidemics may have influenced migrations. Populations decimated by illness left empty lands for others to settle. Human history, in a sense, is a record of these invisible battles, shaping borders, trade routes, and even genetic diversity. Consider the evidence in ancient DNA. Survivors of epidemics often passed on genetic traits that made future generations more resilient. This interplay between disease and evolution highlights that epidemics were not just obstacles. They were catalysts for survival and human advancement. Today, when we study pandemics, we are glimpsing the echoes of those ancient struggles. Our immune systems carry the scars of millennia, and our social behaviors, from quarantine to caregiving, reflect lessons written long before modern science. Every outbreak our ancestors endured demanded cooperation, foresight, and ingenuity. They were early tests of our species' ability to unite against invisible enemies, teaching lessons that remain vital in the modern world. Ultimately, ancient epidemics remind us of a sobering truth: survival is never guaranteed. It is shaped by adaptability, knowledge, and the connections we forge. The lessons of the past are a guide, showing that even the most insidious threats can be faced if we combine resilience, intelligence, and empathy. As we look back across the millennia, the story of ancient diseases is not merely one of death and suffering. It is a story of resilience, ingenuity, and survival against invisible adversaries. Our ancestors faced threats that were immediate, merciless, and utterly unpredictable. Every outbreak was a test of human adaptability, forcing communities to innovate, cooperate, and pass on knowledge that would ripple across generations. These epidemics shaped humanity in ways we often overlook. They influenced migration, social structures, and even the evolution of our genes. They taught lessons about caution, observation, and unity, lessons that resonate in every act of public health today. The scars left by these invisible predators are woven into our DNA and echoed in our cultures, reminding us that survival is rarely solitary. It is collective, passed down through both genes and wisdom. Yet, there is a haunting mirror here. Modern humans, with technology and medicine at our fingertips, still face the same principle: adaptation is survival. History whispers that even the mightiest species can falter if knowledge is ignored and connections are broken. The ancient epidemics were more than events. They were tests of human resilience, and those who survived were shaped not only by the pathogens but by their courage, cooperation, and insight. So, as we reflect on the story of these ancient human diseases, we must ask ourselves, are we learning from the ghosts of the past, or are we destined to repeat the trials that once forged our species?